Hi, everyone. Welcome to my presentation, Pen Testing with Kubernetes, or Brain Dump from my last 4 years. I am Matt Hamilton, also known as Aaroner. On Twitter, I'm the Aaroner. I'm an open source developer and bug hunter. I do bug hunting and security bugs for open source projects. Previously, I was a consulting penetration tester at Bishop Fox, and now I work at Soluble doing Kubernetes and cloud native security things. Application security. I actually kept this picture. This is the default keynote picture. I kept it because it was nice and serene, which is in stark contrast to the rest of this presentation. Oh, fair warning to all of the viewers. This presentation is a brain dump, and by its nature will be rather disjointed. I'm not going to butter you up for 30 minutes and then tell you something great, one great thing at the end. Rather, I'm hoping that everyone has a few useful takeaways. So you've been warned. Okay, application security assessments is a lot like being a home or a code inspector. There are some requirements, but it's mostly art and not a particular science. You have some amount of time to poke around without disturbing the inhabitants too much, looking for things that are ultimately going to just cause them frustration and headache. The only difference in software is that, unlike being a home or a code inspector, there are no rules. It is the Wild West. So application security, I spent years turning Fortune 500 companies upside down, and the majority of the issues that I identified could have been identified by SAST or DAST tools. And I know some people think, oh, well, having SAST or DAST tool catch everything is a pipe dream, and they're right, it is. But when applied correctly in the right ways, they end up picking up a whole lot of issues. And a lot of the issues that I found that were high severity but low hanging fruit issues were just due to test coverage. So this is a question I get a lot. How do you decide where to look? What is your approach? I've heard the quote that intuition is experience distilled. And I like that quote because it allows me to avoid answering this question. In reality, these are the things that I'm typically looking for when performing an application security assessment. All of these issues are high impact issues, and they're common enough between assessments. Now, not every assessment is going to have all of these issues, but they are relatively common. I'm sure that this audience is probably familiar with most of these issues, so I'm not going to spend too much time on them. But for those who are unfamiliar, I will go over a quick summary. Warning, all of these examples are contrived. Some people might say, oh, this isn't SSRF, it's an input validation issue. And you're probably right, but this is just a demo. So, code execution. Code execution is the number one thing that you want in a Kubernetes environment or otherwise. It means that you have control of the application such that you can run whatever code you want and coerce it to do what you want. It is keys to the kingdom, kind of. And what I mean by that is applications that run in Kubernetes are run in Docker containers. And Docker containers generally only have files and services and things that are accessible to them that are necessary for that application to function. It's not like the olden days where you pop a Linux box and that one Linux box has got everything on it. And you're able to escalate either vertically or horizontally due to the scope of information that's available. So today you can steal code, you can hijack the application, you can modify application logic, you can read files on the file system, but it's not always necessarily keys to the kingdom. SSRF, convincing a server to send a request on your behalf. Ultimately, you're convincing the server to send a request itself on your behalf. So for in the first example, it's sending a request to Johnny, and it's just appending .com, and it's sending the message that you send. However, it could be exploited by not giving it Johnny, giving it another domain, and then it will just append .com to the end of the path, and then you send whatever data you want. Well, it looks like the formatting's a little messed up here, but cross-site scripting. This issue is super common, although I'll get into a bit why I'm not a big fan of this alert box here. Oh, formatting's messed up here. Not every cross-site scripting is a critical vulnerability. This, for whatever reason, a lot of reports that I read, the proof of concept cross-site scripting, in other words, popping up this little alert box that's on the right here, that will be in the report as a critical vulnerability with no other information. And this really frustrates me only because, having a cross-site scripting vulnerability in a static site application has no impact. It is not a critical vulnerability. It has no impact. So if you're writing reports with XSS, do the extra legwork. Denial of service issues. A lot of people don't like denial of service issues, and I don't quite understand why. I understand that you can take any site, you can, DOS any site really, and there are 100 ways from Sunday to do it. However, I follow the 30-second rule, which is if I can test for and identify and also exploit the denial of service vulnerability in less than 30 seconds, then it needs to be remediated. So these are just a few examples of issues that I discovered. The first one, it's not quite rendering right, but in the name parameter, there is an emoji character. The Alpine package repo died when you gave it an emoji character in the search. Now, this only affected the web interface, very low impact. My takeaway there is to always search with and do things with Unicode characters because sometimes applications just don't quite handle them right. The second CVE is a vulnerability against Mastodon. Mastodon is a federated social network similar to Twitter where people can run their own servers and software. In this case, if you search for a user, an unauthenticated search for a user at a domain that doesn't exist, the server would attempt to look for that domain and never find it, and it would eventually lock up with a very few requests, and you could take down pretty much any Mastodon server. Moderate impact because it's a social network, Okay. The last one is the most interesting just because of what it is. If I identified a vulnerability in Keycloak. Now, this particular denial of service is extremely common, and that is during a post request, setting the content length header to a value that is larger than the actual size of the data that you're going to post. So this will trigger it not just with 999 or some other absurdly high value. If you're going to send 2 bytes and you set a content length header of 3, that will trigger this vulnerability. And it causes the server to keep the connection open, expecting you to send that last byte or those last few bytes. And so with a very low bandwidth connection, you can take a server down just by consuming all of the network threads available to it. And again, this issue is super common. It's extremely prevalent. And then, of course, there are application-specific abuses. So those are the things that I'm looking for generally when I'm testing an application. So on to Kubernetes. So what is Kubernetes? Kubernetes, like Terraform, is a way to declaratively define infrastructure configuration, meaning that no one is logging into an AWS console and performing, an imperative approach to creating infrastructure. No one's SSHing in and running commands. It's not, ClickOps, clicking through an AWS or some other console. It's declarative. Typically, the files are defined in configuration, committed to Git, and then CI pipelines and operations built around that Git repo apply that infrastructure. In reality, this is what Kubernetes actually is. You end up just writing a whole bunch of YAML files. So whenever someone says, "Oh, they do Kubernetes," what they mean is that they write a whole bunch of YAML files all day. So why should I, as a security person, care about Kubernetes? And the answer is inventory. For both operations, non-developer, operations and security people, I think the inventory aspect is the single greatest part of Kubernetes. So for example, Kubernetes has a lot of individual constituent parts that share a common way to define them and to define their options, and they're all queryable by a similar API. So it is a unified collection of resource types. So there are types, load balancers, services, pods, config maps. You can see some of those things in the image on the left, and then the commands to retrieve those in the text on the right. And I think that being able to query and to be able to show all of this stuff in a unified environment, and the thing that makes it different versus just being able to list all the things in an AWS or Google Cloud environment, is that you can run your containers on Kubernetes on bare metal. You can run it in AWS on EC2 boxes, or you can use their managed service. Same with GKE and just about every other cloud provider. So the inventory is what's invaluable. So here's a list of Kubernetes relevant tools. I'm not going to go into every single tool. I'll go into some of them. But if you really want to get a good handle on all of the different Kubernetes tools that are available, especially if you're analyzing the security posture of Kubernetes itself, a Kubernetes cluster, that's not exactly what I'm talking about. I'm talking here in this presentation about application security for applications running on Kubernetes. So check out this repo if you want more information about all types of Kubernetes security stuff. This is a great resource. Okay, container scanning. I'm somewhat critical of container scanning. Container scanning is frequently used in the industry to you scan a Docker container, you scan a container, and it will tell you, okay, it has this many CVEs and they're of this severity. I think the value of this is somewhat dubious, only because how often does so to back up, all of these container scanners, for the most part, there's like one or two exceptions, but almost all of these container scanners scan the container for vulnerabilities in operating system packages installed in the container. So the question then is, how often of the critical vulnerabilities that are identified in a container's operating system packages, how often does that vulnerability manifest itself to become exploitable from the application layer? So in other words, when a new critical vulnerability is introduced into an operating system package and published into a container, how often is it that vulnerability is useful in an exploit chain that originates from the application layer? And I think that is ultimately very rare. I think it almost never happens. There are some exceptions, but I think it's overall very rare. But people go wild for this data, so. And it is worth doing, because sometimes you do catch things. It's just not very often. Okay, CIS benchmark. So CIS benchmarks are provided for lots of different applications and technologies, and the CIS benchmarks are generally configuration benchmarks. So that for applications that accept configuration, Kubernetes, Nginx, Azure, GCP, AWS, there are lots of different benchmarks that exist, and there are lots of utilities to apply these benchmarks for the different types. You can download the benchmarks, and they're just PDFs that list out a whole laundry list of items. For the CIS benchmark to have value, you have to understand what it is that the CIS benchmark is actually testing. And a lot of the violations are not going to be relevant to an organization or a particular configuration. But there's no way to know that without a human looking at it. KubeTap. KubeTap is a tool that I created to deploy MITM proxy in front of Kubernetes services. I was running into an issue where I needed to proxy services within a Kubernetes environment whose web interfaces were not necessarily exposed or otherwise accessible, but that application received network traffic from another application. So, for example, look at the diagram on the right here, and look where the red box is on the bottom. So you have two services, microservices B and C, that are sending traffic to microservice D. And I wanted to capture the traffic of microservice D so that I could see what traffic was coming in. But if you look on the left, normal web application testing only captures and provides an intercepting proxy just before the browser. So you're generally only ever capturing or debugging traffic that is originates from or is destined to the browser, and which does not solve the use case of deploying an intercepting proxy for microservices within a infrastructure. And the reason that I created this was ultimately because I was looking at architecture diagrams that look like this. As a consulting penetration tester, you'd be dropped into a Fortune 500 company, and you've got 2 weeks to look at their diagrams, figure out what they're doing, and then provide a security assessment. And when a diagram is as sprawling as a lot of them ultimately become, especially for organizations that are heavy on microservices, it's very difficult to debug those applications, only because a lot of the integrated debugging that those developers of those services have provided is typically outputted into log files somewhere that I don't understand the relevance of those log entries and what exactly I'm looking at. So I actually need to see the network traffic. So here's a demonstration of KubeTap. I'm installing Harbor, which will be our proxy target, and then I'm using KubeTap to port forward and open a proxy. It's sped up a little bit here, and it's kind of so it's outputs the URLs here, and it will automatically open the browsers for you. So here it automatically opens the browser to our Harbor target, and you can see the entry on the left there of attempting to log in and successfully proxying that service. And Harbor is not necessarily the best interface because the best example because it has a web interface, but there are lots of applications that simply don't have a web interface. So the question, why don't you just reverse proxy with Kubernetes natively using Burp Suite or another proxy? And the answer is because Kubernetes doesn't support it, interestingly enough. It's been almost 5 years since this issue was created, asking for a reverse port forward from Kubernetes. Kubernetes currently has the option to port forward ports in the forward direction. In other words, bind a port on your local machine to reach a service within a cluster. But you do not have the ability to bind a port within a pod in a container, an application in the cluster, and then send that traffic back to your machine. That is not currently possible. I do have a ticket to when this functionality is implemented to implement this because I'm very much looking forward to it. Helm. This is a Kubernetes templating tool, and ultimately, some people hate Helm. Some people love Helm. I fall somewhere in between. It's got its strengths, it's got its weaknesses, but the big strength is that Helm is very fast to deploy applications. So Helm version 2 is bad, and if you come across an environment that's using it, you should tell the people who run that environment to stop using Helm version 2. Helm version 2 is vulnerable to an unauthenticated takeover. And because Helm exists in a privileged space within the cluster, it's an unauthenticated cluster takeover that's just waiting to happen. And I say this because I've compromised a lot of organizations using this vulnerability specifically. So using Helm v2, don't use it. But the great thing about Helm is that it's templating of Kubernetes, and it makes deploying stuff very easy. And again, that is the big boon that Helm provides, is the ability to look at a commented template file that a human has written to make logical decisions about your infrastructure and the way that you would like to deploy the application, and then to deploy it and manage upgrades and all the rest. And so this is a screenshot of me running Helm as in the KubeTap demo. And you look at the last command there, that's me installing Harbor using Helm. And it is, in fact, pretty much that easy. In a lab, I will say in a lab. In production, you'll have to conform to security constraints, ideally, that are implemented by the cluster administrator, and it might not be quite that easy. So this is a brief aside on testing infrastructure variety. I mentioned at the very beginning that a lot of the issues that I identified probably could have been caught by SAST or DAST tools. So where do security tests belong? There are different types of tests. Unit tests validate the code that exists on master. Integration tests validate the cross-service functionality, and end-to-end tests validate the whole picture. Unit tests are generally written by the developer who wrote the code with the implicit bias that the developer expects the thing that they created to work. End-to-end tests test the whole picture, and is where most of our security tests live. So the way for unit tests to work is that ideally you have peer review, whether it's automated peer review with, again, SAST or DAST tools, or whether it is true peer review. But I hopefully, you don't have a whole bunch of no lints or, no security exceptions everywhere. And then end-to-end tests observe, the whole picture and are generally run against a demo environment, a pre-prod environment, a production environment, or some mishmash of those. The question is, are these targets sufficient for security testing? And I posit no. And the reason is very simple. And this is based on my own experience as a penetration tester. And I bring it up in the context of Kubernetes penetration testing, because the one thing about Kubernetes penetration testing and Kubernetes in general is that things are generally designed to scale, and they're designed to scale dynamically. And everyone's okay with failure. Everyone's okay with a database or things becoming overloaded because it will scale, and that is fine. And that's a fine approach. But what that means is that any security testing or testing that you do has to take that into account. So imagine a scenario: you have service A becomes disconnected from service B because it becomes overloaded for whatever reason. There's a configuration change within the environment. This is not an explicit operator-defined configuration change, but it's a configuration change nonetheless. And because that application is disconnected, it produces, when visited by a web browser, it produces an error endpoint that is vulnerable to an XSS or SSRF or some other type of vulnerability. Unless you're testing the failed state of the services, this particular failed state, no SAST or DAST tool is likely to catch this issue. I mean, maybe, but unlikely. And this is, by the way, where I found a lot of issues. So when you go into a company to perform a penetration test, it's extremely often that they're not exactly always prepared for you. There's setup and getting you access and getting a test environment available for you. And a lot of times that's where you observe this breakage. And it can lead to some quite devastating issues. So I have a dream tool that kind of resolves this. I don't know what this thing is. It looks cool, but highly impractical. So remember these issues, all these issues that I talked about earlier that I'm looking for. I want to find those issues, and I want to find them in configuration states that are otherwise not generally tested. And so if using Helm, I can create a variety of configurations for a given application. So for example, an application might support using Redis versus an internal cache. It might support two database types, Postgres or MariaDB. It might allow local auth. It might also allow OAuth. You might have a feature flag that enables Slack integration. There are lots of different types of application functionalities that can only really be surfaced, and feature flags that can only really be identified and surfaced by a human being. In theory, you could brute force every possible option of a Helm or any type of infrastructure configuration, but I don't think that's quite feasible. It would require the compute resources that would require versus the coverage that you would gain from that is so lopsided that I don't think it's worthwhile. So ideally, I would like to be able to provide a baseline chart and then send a request or multiple requests to a variety of configurations. So not just production, not just demo, not just pre-prod. I want to be able to send it to services in a variety of failed, working, or otherwise state to be able to see what happens. And I guess you could somewhat call this infrastructure fuzzing, but again, that would apply that it's something that's not a human making the decisions about what needs to be tested. And the tool that I imagine would look something like this. It is going to be some amalgamation of, if anyone is familiar with the Burp Suite plugin, auth matrix or CI jobs, just a list of matrixed CI jobs. That's what I'm looking for. It's going to be some amalgamation of those two. And someone might say, oh, well, this is just chaos engineering, and that these test environments need to be random to attain 100% coverage. And they're right. That would be the true fuzzing approach to gain complete coverage. But I don't think anybody needs 100% coverage. You need test coverage in the things that are going to have impactful vulnerabilities that you would otherwise fix but aren't aware of. So if anyone wants to finish drawing the owl here and build this tool, that would be great. I don't think it would be quite that hard. It's just not something that I have room on my plate to do. Okay, back to the program. So we talked about Helm. kubectl is the interface, the command line interface to Kubernetes. You're going to be using this command a lot. As a security person, most of the time you're going to be looking at application logs for the results of your actions to see what's logged, how it's logged, and if you're doing any type of blind action, logs are very useful. You may be running a debugging container within that environment to examine the network configuration or the accessibility of services. And I left off here, but it's under the same lines as the run command. The exec command, which is to run commands within a Docker container. Now, of course, you won't have this privilege in production, but you should in a demo or testing environment. Other Kubernetes debugging utilities. kubectl debug can be invoked as a kubectl plugin in the same way that KubeTap can. So rather than typing kubectl debug here, you can just type kubectl space debug. Easy sidecars. When you have a pod that crashes and you don't quite know why, this is a great tool to figure it out. If you're into debuggers, Squash is for you. I'm not. Debuggers are not my thing. And if you're auditing permissions within a Kubernetes cluster, you're going to be evaluating RBAC, role-based access control for the Kubernetes environment. And if you're doing that, RBAC view is a much nicer tool for doing that, for listing out a matrix of all of the permissions that are accessible. It has not been patched or had any updates in 2 years. It's been a while since I've personally run it, in more than 6 months. I don't know if it still works with the latest version of Kubernetes. It's a little bit slow. But it's better. It's better than nothing. It works pretty well. Useful in-cluster tools. So these are tools that are not necessarily run by you external to the cluster, but tools that are useful to me personally when run within a cluster. And the first is XSS Hunter. If anyone doesn't know, if you do any type of web application testing and you're ever testing for cross-site scripting, this is a tool by Matt Bryan or Mandatory, and it is fantastic. Great tool. Thanks very much, Matthew, for making that for us. Send by Mozilla. I was real bummed that disappeared, and that Mozilla is no longer maintaining it. But the code is open source, and so I now run it in my cluster. Cartography by Lyft is a tool that I'm not running yet, but I watched a presentation a couple days ago about it, and it popped up on my radar before. It's essentially a mapping tool for AWS, Kubernetes. I think they do have lots of different data sources. It's a visual mapping tool, and if it could be worked quickly, and it's easy to import data, it's not something that I've explored, but it looks like it has a lot of potential for providing a visualization, which would be great for consultants and people who are otherwise not hyper familiar with any given environment. So of course, this is I guess this isn't a real presentation if it doesn't contain top 10 tips to wrap this up. So I am a programmer, so I index by 0. So tip 0, build a debugging container. I initially spent a lot of time, more time than I would like to admit, running commands within a debugging container to install all of the packages that I need every time that I occasionally needed a debugging container. And it just became frustrating. I highly suggest creating a debugging container with your, a shell that you're comfortable with and all of the tools and everything that you need. And I suggest making one with Alpine and one with Ubuntu or Debian or a normal glibc. The benefit the Alpine containers have is that they're very small. They're very fast to download and extract, and minimal dependencies, essentially. The problem is that they're linked with Musel, and as a result, there are glibc incompatibilities with if you're doing trying to run any standard Linux binaries that wasn't specifically compiled for Alpine. But as long as you're not doing that, use Alpine. It's great. Debug the network traffic before debugging the application. when trying to identify what an application does within Kubernetes or on any type of application security test, before you begin looking at the code of the application, other than unless you're grepping for known things that are terrible that people do using CodeQL or some type of SaaS or DAS tool, before you begin any type of manual analysis of the application, I strongly recommend debugging the network traffic. I'm not quite sure. I've noticed that a lot of developers are hesitant or aren't aware. It's just not a part of their workflow to debug network traffic. But at least for me personally, it is the single most valuable thing, because most applications in Kubernetes or elsewhere, they consume network traffic to provide a service, and the service is the result of the network traffic. So you're essentially looking at the master inputs and outputs for the application. Now, of course, there will be application-specific things that makes that statement not true, but the network traffic is generally the place to start and has the most value of your use of your time. Okay, test applications with all configuration options, and this includes infrastructure. So this gets back to the testing error states of applications. I think being able to use Helm in Kubernetes to spin up a vast amount of infrastructure and applications with varying configuration is a feature that has not existed and didn't really exist even with AWS and EC2 and the other cloud providers and Terraform, Ansible, all the rest. I mean, you could do it, but the speed at which you could do it was such that it made this impractical. But I think this is much more practical now, and it would be nice to see more organizations doing this, and it would be extra nice to see somebody make that tool. Okay, aliasing the kubectl command, and I'm serious about this. The amount of times that I typed kubectl before I aliased this is kind of comical. I have no idea how much time I spent typing, ubectl, but it was probably a lot. So you have a couple options. You can just alias kubectl as k, or you can use a tool called kubectx, which also has the benefit of managing Kubernetes context, meaning if you need to connect to multiple different Kubernetes clusters, you have a prod cluster, a demo cluster, and a pre-prod cluster. If that is your configuration and you're running disparate clusters and you're not running them in isolated namespaces within the same cluster, kubectx is a nice utility for that. It's very popular. However, My problem with it is the same problem that Darren Shepard had, is that at Rancher Labs. I needed a tool like kubectx that did not modify any of my on-disk configuration files, because I wanted to be able to run Kubernetes commands in different terminals, with each of those terminals connected to a different cluster, and to know that and to know that those commands destined for that cluster would end up in that cluster and not cross communicate as a result of updating the configuration in one shell with kubectx. And so I know the picture's hard to see on the left there, and it's kind of small, but that's kind of the point. It's about 11 or 12 lines of POSIX. I also have bash and ZSH implementations, and this allows you to type k prod or k demo or k whatever, and then finish the rest of your kubectl command. And then anytime you use k in that terminal until you close the terminal, you no longer have to prefix it with the environments. You no longer have to type k prod. You can just type k get po or whatever your command is. And so you do have to customize this a little bit to match your environment, but it's also not it's not a binary, and it's not some multiple hundreds of lines of shell script. Tip 4: implement network policy objects. Most Kubernetes clusters by default essentially allows all RFC 1918 addresses within the cluster, meaning they allow all of the private LAN connections within the environment. The stipulation being that depending if you're running in a cloud environment, depending upon depending upon the configuration of the cloud environment's firewall and how integrated the network is for the Kubernetes cluster that you're inspecting. So EKS versus just running on bare metal in EC2. But Kubernetes itself, by default, will allow all internal network traffic with no restrictions, unless and until you implement network policies. And you remember when I mentioned earlier that Helm v2 has problems? Well, Helm v2's problem is that it does not have authentication, and the lack of authentication allows you to perform administrative tasks within the cluster. And by default, Kubernetes does not restrict inter-cluster communication. So I hope you can see the problem with that. If you achieve it in a command execution or SSRF, or generally the ability to send requests to internal endpoints within the cluster, it can end up with quite the disastrous circumstance. Security baselines. Very frequent question is, what options do I need to set in a pod for it to be secure in the Kubernetes pod configuration? And thank goodness that I don't have to recommend that people write it out and then run the CIS benchmark and then read all the results and figure out what all of it means anymore, because I think it was about six months ago, it might be 8 months more than that now, Kubernetes published a set of pod security standards, and it provides, I believe, 3 different policies. There's a baseline of restricted policy and then a more permissive policy. And you can apply all of those configuration options to any given pod and know that the general description of those baselines is correct. So if you apply a restricted policy, you will have to provide exceptions to that policy for your application to most likely do the thing that it needs to do, and that's okay. These are the baselines that you should ideally work from. Tip 6, look for denial of service issues. Again, I know there are some security people that say, well, denial of service doesn't matter, you'll always have them, and it's just the nature of the application. And again, that's true, but I recommend using the 30-second test. If you can identify it in 30 seconds, and you can write a shell script to exploit it in 30 seconds, then you rate the severity appropriately, because the bar, people are kicking the bar with their toes at that point. Tip 7, somewhat related to tip 6, put Unicode in places where it doesn't belong. Sometimes this results in a prize. There are lots of instances of this. This is something that I ran into as a penetration tester all the time. This is one of the tips that's not directly related to Kubernetes, because I don't have any stories of any direct Kubernetes things having any Unicode problems, but there are lots of applications that don't quite handle Unicode correctly, and it's worth testing. Tip 8, I mentioned it earlier, RBAC view. This is the matrix that it provides. This screenshot's not great there, but it provides a breakdown of what users have what permissions within a cluster. If you do this by hand, unless you know what you're looking for, it is going to be very frustrating. It is very frustrating to audit RBAC roles if you don't know what you're looking for. This interface is great for a high level and a starting point in auditing RBAC roles. And last but not least, again, destroy Helm version 2 with the Fire of 1,000 Suns. It is, if you go to the Bitnami link there at the bottom, the post was written by Angus Lees at the end of 2017. And that was about when I first read this. It is extremely surprising. And I know that there are some organizations, I believe also Darren Shepard also mentioned this, but there are some, or it may not be Rancher Labs, but there are some organizations that are using Helm version 2 for some, for reasons. And unless you fully understand and comprehend this particular issue, the fact that Helm allows unauthenticated cluster takeover, essentially, without you taking, a lot of steps to solve that. Tiller, which is the daemon in cluster server component that allows this to happen, is, let me put it this way. Tiller, the component that allows this to happen, has been entirely removed with Helm version 3. I don't care what article on the left here that you click to migrate from Helm version 2 if you're using it to Helm version 3, but please do click one of them and do it, because this is for the period of 2017 to 2019. This was the number one way into into a Kubernetes cluster. Is you would find SSRF or RCE or some type of ability to send requests within the cluster. You would send a gzip file into Helm. You would deploy a chart, a malicious chart. It does not require authentication, and you would be running arbitrary code in a Kubernetes cluster. It's essentially cluster takeover at that point, because Helm runs with highly elevated privileges. So get rid of Helm v2. Helm v3 is great. I have no particular gripes against Helm version 3. And that's it. I'm sorry that was a little bit rambly, but that's kind of how a brain dump like this works. It's the nature of the thing. So thank you for attending my presentation.